In this third part of the video, I'll continue to give you some examples of how to draw and represent forces and interactions with free body diagrams. And to start with, we're going to take yet another example. Here we're going to imagine a floor, and on the floor we're going to have a crate of some sort, and we're going to have a person pushing on that crate. So this is the scenario. Person pushing on the crate. Now, we'd like to draw a free body diagram of that situation. Maybe the crate is moving that way. There's the velocity that way. And we'll say he's moving at a steady speed. Right now, it doesn't really matter how we say his motion is, but we'll just say a steady speed. So now, what does a free body diagram look like? Well, let's begin by listing the interactions. Interactions. That. All right, so one interaction is with the floor. And a second interaction with the box is the person. And a third interaction with the box is the earth, pulling down on the box. Now there's a fourth interaction, but it's actually also the floor. And so we'll take a look at that as we draw our free body diagram. The floor actually exerts two interactions. All right, so for the free body diagram, we're going to draw a box again. A box is easy, but we use a box to represent everything because we don't need to be artistic about this. All right, let's look at the interactions. We have a downward pull from the earth on the box. And again, we use the symbol W to indicate weight because that's what the special name is we give to the interaction between the earth and the box. And again, on this diagram, we're going to draw all arrows the same length because we have no way to judge their relative lengths. As we get there in the next couple of days, we will certainly have ways to judge which should be longer. Also, we have an upward push from the floor. We call that a normal force, as indicated in part 2 of this video series. And that's going to be floor on box. Then we have a push this way, and that's going to be a generic, not a special named force, person on box. And lastly, we have a resistive force of friction, assuming that floor is not too smooth, friction force from the floor on the box. And we're going to use a script F to indicate friction, and that is an interaction between the floor and the box also. In fact, if you read the reading on named forces that was assigned, you would see that this is an interaction because of the roughness of this on the surface of both the floor and the box. And so that particular way that interacts is backwards against the box. So there is a representation of the forces, the interactions with the box. Now I'm going to quickly do another diagram, this time between for the person. There's a free body diagram for the person. And so on the person, you have the box pushing that way, force of box on person. You have the normal force from the floor on the person. You have the earth interacting with the person. And you have the floor interacting actually this way, the grippiness of his shoes, floor on person. And that's actually a friction force. And the only forces in both these diagrams that we know are the same is that and that. That's person on box and box on person. Okay, so now it's your turn to try. And you can prepare these for Monday by bringing them in on a drawn on a sheet of paper. These force situations: a boy stands on a board across a river, and do the diagram for the boy and for the board. And then the hill,